ওকে দেখি এবার এখানে আসো আমি ইয়ে করি চ্যাট গুলোকে বার করি এখান থেকে
The YouTube chat is showing this, so I have to keep a track how many which are coming, what are coming.
Then have a tool and sit.
No, that tool is for daddy, so I don't have to go and give it to this.
you can sit here oh no not this
I am giving you another tool. Sit.
It's okay. You can use that.
you wanna run around or what
No, I prefer standing more. Just like
okay I'm live by the way
Yeah, cool.
what do you say?
I'm live already this it is streaming
So what are you gonna talk to them?
I'm gonna set up the menu today
Menu?
What is a menu?
yeah
It like sounds like
file
menu
server.
on
wait a second দাঁড়াও কেন টুল তো আছে তো আবার কি আর দুটো কেন লাগবে
Oh, বলেছে you need that to keep things.
no I don't need that to keep things you can sit there এতগুলো টুল এখানে রাখিস না রে
Okay, keep it here.
right first of all
Did you post?
huh
Did you post?
did I post yeah I did post all right chat here's the chat let's pop it out
So today is Twitch,
all of
YouTube?
them same
Twitter.
same ones no Twitter this one I'm not anyway Twitch yeah uh-oh god damn pop out chat all right cool I need to start flashing I need an SD card micro SD card that I need to flash first
do you need one or two?
I need one
So this is one.
yeah
So I need to take both of them. You can just slap on one and then just use it.
that was a mistake
Wow.
what happened
There is a delay, right?
there's like
When
no
do you live chat?
so this one the live streaming breaker space one there is no delay it's ultra fast low latency the only thing is that you cannot do 4K which I was not doing 4K anyway and there's also no closed caption CC corner baba
Oh.
but it makes the interaction much faster because we can talk to the people faster respond to the like anybody who is asking question faster
What do you need from the computer?
nothing baba আমি একটা জিনিস করছি হ্যাঁ
Today you are using only this camera.
let me say that I'm starting soon think my
Starting soon.
starting soon isn't like I'm gonna sit with this soon I'm just let me
Did
flash
you
the
give a brief like what you are doing today?
it's in the it's in the description
It's in the description. Okay.
Isn't that my tool?
It's okay. Yeah, that's why I have one extra. Okay, help. I'll be here after some time.
what?
I always wait for this moment to arrive. I love this.
Why is it so 32 MB করে না বকা খাবে
Just like whistling too.
yeah so how Why would you whistle when there's a streaming going on? Something's wrong with this one. Should I try reading this through the micro SD? Yikes.
So when will I look at the chats?
What if I just format the partition? Don't think I should. Wait, let me read this on a different device first. For example, oh, I can put it over there. Never mind. Hmm. Nope, there's something wrong with this one. I need to change the pen drive. The disk you attached was not readable by this computer. Eject. Alright. Alright, I'll figure that one out later. Let's keep this one aside. On that note, let's try out the Raspberry Pi SD card, micro SD cards.
Let's try that.
Hmm.
I really want to. I don't know what new thing I discovered from that.
Hmm.
Really makes friends with them. This small friend?
Hmm?
This small friend?
It's a micro SD card. What are you talking
Oh,
about?
it's a card.
Hmm.
It should be in a cave and then connected to that.
I am connecting that. Let's see.
We
Yeah,
use
32 GB drive,
the
master device. Okay, let's now flash
a little bit.
Raspberry Pi imager. Where is Raspberry Pi imager? Imager. Okay. Yeah, I choose device. This is a Pi 5. Yeah, choose OS. 64 GB. Do we want no graphics. 64 GB light. Right. করেন এরকম. Don't jump around. Alright. I would need edit settings. Pi min. everything else seems fine. Let's just go with it. Okay.
Okay.
Yes.
So no
Yes.
problems.
Okay. Now I will turn on the camera, by the way. You can't jump around anymore.
Okay. I'll stay still and assistant.
Okay. All right. We would also need to check if there's any comment. Do you want to check the comments?
Yes.
Let's go find out the comments, okay? Give me a sec.
Off.
Not
PC
off.
one.
We want to go to this.
PC
None of your business. This is wasting my time. Campsite. I'm not watching this.
Sorry.
Hey, sorry, dude, if you feel that way.
I have to feed you, little.
I was working on a different computer. It took a little longer than I expected because his micro SD card wasn't working. Best viewers. Yeah, I'm sorry about the first 10 minutes. It took me a longer. I thought it'd be 2 minutes job, but it took me longer than that. Let me put together the drives. So, I'm assuming these were already, I formatted them. But so put a little bit of context what I'm doing today. I'm going to set up mean.io. That's this self-hosted alternative of Amazon S3, AWS S3. Right. And I'm using this because I need a self-hosted object storage. I will come to the details of object storage and file storage and block storages after. For the time being, let me just check and see if the drives are working fine. Currently, I'm flashing my the micro SD card for the Pi 5. This is the 8 GB model. Okay. I meant to run these drives off of I meant to run these drives off of
I had to feed
the USB port. Huh? What happened?
I had to feed you by the shoot.
Okay.
Raspberry Pi.
Okay, tell me when it's 100%, okay?
Okay.
I would need a micro HDMI cable to capture this. Sorry.
Daddy,
Hmm.
it's 100.
Okay,
now
let it.
another one starting.
Okay, let it verify.
It's verifying its thing.
All right then. So let me.
Okay.
Okay, this is fine. Uh, Soon after we boot up, we will move over to the devices screen anyway. So, oh, I think should have gone with the GUI. Never mind, we'll figure that part out. So this is the keyboard mouse that I'll be needing. Is it done yet?
Nope. It's almost finished. It's 90 now. I've made it over lunchtime.
All right.
It's 96 now.
I might have to type in the URL because I will not be able to.
It's done.
It's done?
Yes, now you just have to click this button. Continue.
Okay. Press continue. We can
Continue.
close this out.
And now
I have
you take that chip out.
Yes.
And then use
And
it in that computer.
yes. And we can move over to the other computer.
The other computer. And then you can click it to where you need to put it so the computer knows
Okay.
what to do.
Sit here.
Oh, I'm more comfortable in standing.
You're more comfortable standing?
Yeah, just like you.
Okay.
I'm
I'm not standing though.
Yeah, because you have to sit and do the work. Or it's a long time.
Yeah, okay.
I already have some things.
Right. So what are you doing today? We are trying to boot up. Okay, I need the other cable. Let's see. Give me those cables.
This cable? Or
No, all these cables. Yeah. Give me those. Give me the tangly one. Wait. Hang on a second. I need to find out the one that shows me the power. This one. Okay. Put the rest of them there. Yuck. All right. So I need to use this cable because it shows the power consumption. And what happened?
Nothing. It's just mommy.
Okay, it's just mommy. Put this one back there.
It's on the black table here. Like the black one.
Right, okay. And let's boot it up.
Let's boot it up.
I think. Oh, what happened? Oh,
What? Mommy again.
let's try with this. If everything is alright, then we should get a display signal soon enough. I think we need to press power. Is it powered on? The fan is not spinning.
I don't think so. It's power on. It's showing red.
It is showing green though, blinking green.
Blinking green means it need to get a little bit more charged.
Overhead camera.
It shows a little yellow.
Why is the overhead camera?
It needs charge.
Transform. Reset transform. right, that makes sense. Okay. Mm, this is not consuming power, so I'm pretty sure this is not using any charge. Let
Is
me
it using any
connect
charge?
it
Because
back
it
again.
doesn't have any charge.
No, it has charge.
But I think it's not using it.
Let's see.
Or maybe it takes time for it to realize when it's getting on. Still not spinning.
What the hell?
Mm-hmm.
Should I change the cable?
Yeah, I think so. If the cable doesn't work, then we have to take another one. Yeah, the right one already told me.
Can I move the mouse a little bit? Did this Pi had any problem before we open it up from there?
No, I don't know that. Not to my knowledge.
It's not booting up. Where's the other one?
Other what?
Other Pi, the 4 GB one.
There? In that place? Oh, the other one is there. Outside it was running Rise.
Rice?
Rise computer.
That's
Pi 5.
yeah, Pi 5. That's this one.
It has a problem?
I mean, it's not booting. I didn't open it for like a couple of months.
Maybe it got a little bit rusty in its immune system or the functioning. I made a
এত
joke
বাজে
for
বকছে, বাপরে বাপ।
It's just a joke for the video.
Today I have
Come here.
decided not to say anything.
Come
Whatever.
here. Sit. Sit and watch.
Like it's making the video look funny. It's getting pretty boring.
Yeah.
I think it's in the drawer. Leave that drawer. Where you keep all the pies.
What drawer is this? 1, 2, 3.
Top one.
1, 1. Okay. Ready? The first drawer has all the pies. Better check that one.
Let me check that one. Where's the other ones?
I have all the pie 0.
Wait a second. This might
What
have.
is the pie?
Yeah, this has another Pi. So let's use this one and see.
It could be me when
This actually has a
Is
SD card in itself.
Let's see.
Okay, let's see this one. Okay, okay. Okay, do it. Yeah, the power supply place is hot, but rest of it is not. Yikes. Let's sideline this Pi and use the other one. This one should be 4 GB model, but that shouldn't impact our use case here. It also has a SD card that is attached already, so I'm just gonna keep it as it is and see what's there, because if it has the GUI, then it'll actually be more helpful for us to work on the Yeah, this one is booting. This one is booting just fine. So there's something wrong with the other Pi. This one is having some booting issues. I need to debug it after. I'll probably debug it after we get it working. Let's go to the overhead camera. Sorry, the HDMI capture. It's not capturing. Oh wait, it is capturing. This had the wrong window. Okay. Hmm. Right. It will be pretty difficult to see it this way. I think I need to change the layout. Let me push this out here. What the hell? Right. Okay. So this might be a little bit better, but still I think I should reduce the size from below because most of the text is actually at the bottom. So how about something like this? Something like this. Right. Please don't do this. It's very like distracting. So the mouse won't work, but the keyboard would. Okay. So now a little bit of dispose exposition, not disposition. So let's open up the window capture. Firefox. Yes. Yeah. Okay. Let's open up main.io. So what I'm trying to do here is basically set up self-hosted object storage server. Main.io, main.io or Minio is such a solution which is Amazon S3 compatible. That means that we can basically set up the server. We can set up the server and we can use it as a self-hosted Amazon S3 solution. With full API compatibility. Right. We haven't yet checked out if the devices are working. So let me check first that LSBLK. Okay, so the drives are not mounted. Mhm. I think I'll need to reattach the drives. Uh, there might be some USB power limitation as well. I'm not entirely certain, but let's see. Okay, the drives are not being recognized here. One thing that I can do to verify them is to test them out on a different system first, and then come back up here. Let's check them out on my desktop.
Drives are not working.
Hmm?
The drives are not
The drive was not being recognized for some reason. Maybe the power issue, as in these things need plenty of power to spin up, right? These are the spinning hard disks, these are not the SSDs. So if the PI's USB port is not giving it enough power to spin up, it might have some challenges. So that might be a reason. Let's see if it is able to power up here. Yeah, it's spinning. So
recognized.
let's see. Manage. I think I should check it out from Linux, but yeah, that's a better option.
Is it working?
No, as in I cannot see that. It takes forever to open the disk manager. I think by that time I'll use the second one on the second computer.
These are two hard disks.
Right.
These called spinning hard disks.
Spinning hard disks.
Yeah, take from here.
Ah.
There's a disc. Can you see the disc?
That is what we call the disc. It is disc.
Have you seen the normal disc that are
Yeah,
outside?
it's
Circle one.
no, I've never seen the circle one.
DVD. We used to call it DVD. CD.
Oh yes, I've seen that.
Yes.
Those are hard disks.
No.
I've seen those. It's circle disc like this.
অদ্ভুত আওয়াজ হচ্ছিল না?
Yeah. I thought it's because of spinning.
Spinning or not, it should not cause that much sound.
Is this the new one or this
No,
is the
these
old?
were the old salvaged ones. I'm just doing them like running a test for this. I would use better ones.
I think you should use a SSD.
I should use the SSD, right?
Yeah.
Okay, let's skip over this one. That kind of sound should not happen. So let's put them aside. For I don't know why today everything I'm like trying for the first thing is not working.
Okay,
Like
I
the
have a question.
micro SD, yeah.
Do these two discs have any data?
No, they shouldn't.
They shouldn't.
They shouldn't have any data. Like as in, I have that part I have taken care of. So the micro SD card first one that I tried didn't work. I had to flash the second one. The first Pi didn't work.
I think it's like a performance pressure or something because we are sitting here. That's why.
The performance pressure of the drives.
Yeah. We are sitting here today. That's why.
Oh, god damn it!
Nice video.
Nice video, right? 240, 240. Let me just verify that they have nothing in them. They shouldn't have nothing in them, but anyways, still, let's just very validate that anyways. What the hell? I'm now starting to wonder if these adapters are problematic or not. Might be. This is.
Why are you hanging it like
It doesn't matter. That doesn't matter. No, no, no. Cables are fine. Okay. Does it have anything? It doesn't have anything. It's blank. Okay, cool. So stop it. Let's pull it out. Or maybe let's keep it with that. Let's try the other one.
not working?
Murphy's law. Everything that can go wrong will go wrong. Only thing is that today is going on. This is the first try.
Maybe
This
this
makes
cable
no
is
sense.
not working. Check with the other cable.
Let's try with the other cable. Even this cable was not working until it started working. So it's just being random. What if I just use one drive for the time being? This one does work. I just verified it. What if I
What do you want to show?
wait a second? I can just use those uh, enclosures.
Yes.
Yeah. Oh, those need type A to type C. I have type A to type C.
there.
All right.
So is it necessary to have two?
Yeah. So basically, Minio requires that we have redundancy. How do I open it? Oh, okay. This way. Okay, the second one. Huh? Yeah, so it kind of enforces that you have redundancy. So if I'm not mistaken, like last I checked, like today I'm checking it out after like almost a year now. So I've been planning to do this for over a year, and I haven't tested like checked the documents recently. I was trying to do that live on stream. So last I checked, it we were supposed to um, you were supposed to set it up. I'm doing it with Linux directly. No Docker, no Kubernetes. Okay, right. Let's open up the window capture. And
It's like having your own storage.
own
Cloud.
AWS cloud storage. Yeah,
Cloud storage.
yeah, it's AW compatible. All right, so with that, I need two of these data cables. Okay. I'm pretty sure somebody's on chat. I am not. I Yeah, probably. Wait. Let me move over to the other computer.
Go check.
No, no.
Switched.
I switch. No, it's fine. It's alright. Mm-hmm. I think I should first still check these ones again back here.
You're not checking the Linux.
I'm checking on the Linux.
Do not like this hanging thing.
And I like this.
No. There can be problem with the cable. Loose हो जाता पारे.
That's it. You have to pull.
I
No. It's free falling. Gravity might pull it down.
Yeah, I like it too. It's having fun.
It's not good for the computer. Not working?
Not working? Nope. Next one. With loose connection.
Yeah, I'm thinking of loose connection.
It's not loose connection.
Because you're letting it hang. Obviously, not like that.
And same cable, same hanging, working and not working.
I think then there is some issue with the disk because that was a disk you could not read.
Now it's both.
Both you cannot read.
Sometimes you can.
Storage system is so random.
Yeah. It's not really.
Isn't that real?
It might even be okay. How about, is there a different system that I can use to verify this?
You
Because
can use the Mac. No?
yeah, it can,
Yeah, try with the Mac.
but it's streaming right now, so I don't want to basically mess with the cables and connections.
Okay. Do you need the Dell one? Should I give
Dead one?
Dell?
Dell.
The Dell laptop.
Dell. Where? How do we power it? The
From
problematic
there
that way.
itself.
Well, let me try from Windows once. See if that works. At least if it says that okay, the like I cannot recognize the file format, that's still better news than not reading it at all.
Stand and listen. What's the problem right now? No, the hard disk I want to get read.
God, the deadline was made for China.
I'll need to check the cable after. Let's try the other one. Nowadays I'm getting really worried about using USB cables. That one is for Insta360. I'm like, why am I using Insta360 cable?
Active, passive, there can be a lot of things going on.
Yeah, I have.
Massive.
Let's use a type C to CNC because those are data for sure. I know that.
Okay.
তোদের ডিনার হয়ে গেছে?
No, we will go in another 5 minutes. It's dinner time. Fine, it's okay.
What the hell is wrong with this?
Why you are trying so? Take that NVMe.
Which
Those cards.
NVMe?
The one you don't have any spare.
I have 4 spare.
Just use those two. Why you are trying?
What makes you think those ones will work? No, sometimes when shit doesn't work, I'm considering switching lens and trying something else today. Maybe set up the Radza X4 and
Like World War II.
oh yeah, we can unbox those ones as well, right?
Yes.
Yeah, I think this is the curse of Risk V. It's like I am sitting here
For one
not
year.
for 1 year not getting unboxed. What are you
about that
doing with
Quora-
these new things?
Quora TPU
God
have all
damn.
What is goddamn?
It's damn.
It's some curses. You do not say those things, okay?
Okay, who is gonna see that?
I do not understand. When did you change the plan for this Mina?
Why today? As in,
No, you were supposed to do that.
okay, that was day before yesterday when I planned for like the Xplex thingy. That's when. Thought of today I'll do this.
Anyway, it's time.
Okay.
We will be going.
Turn on the video. We have to do the.
No, we are going.
You know?
Daddy can stay. Okay, bye.
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 Mwah. Right. I think I'm gonna switch gear and not do this Minayo setup today. I'm just going to sudo power off. Right. And move over to this screen. I'm gonna skip setting up the Minio today. It's not working for some reason. I'll need to check out the drives, etc. much better the next time. It doesn't really make sense to be prepared for stream in that sense. This is not really a show business. I'm not a streamer in that sense. Um, so if you are annoyed, I know some people visibly are. I'm sorry. Um, Sometimes things don't go according to plan. What you gonna do, right? So a couple of things that we realize is that I need to check this 8 GB Pi 5. I will probably do that after the stream or maybe later part of the stream. We'll see about that. I'm going to move these things away and do some unboxing of these other boards that have been sitting over here for quite a long time. Right, let me just quickly put them back here. By the way, we could have taken the time to set up the, okay, maybe next week we could have set up the zero downtime Pi. So basically Pi with integrated UPS. We can do that next week. This week, let's just go ahead and unbox so this is a risk-free single board computer. This is from StarFive VisionFive. As it says, it's just a 4 GB model. I'm going to go ahead and go through the plastic cover. I still hadn't even taken that one off, so this is exactly completely brand new. This is the first thing. This is more of a dev board than anything else, because at least at the time when it was released, RISC ecosystem was really at its infancy, especially the software ecosystem. So when it comes to consumer single board computers and stuff, and this board among many others have been pushing the limits of what is possible, allowing people to write software for it, test it on the board, and yeah, generally allowing people to create the ecosystem a bit better gradually over time. So yeah, let's do a quick board review. I'll go through the board and add my thoughts. So this is the SoC. If I remember correctly, it's a JH7110, StarFive's designed SoC. Yeah, it says so on the board. If you look at up close, I can't really see it. It looks like very fine print, but I'm pretty sure, yeah, on the screen it shows. um, yeah, so that's the centerpiece. That's the RISC-V or RISC-V open source ISA, instruction set architecture. If you're new to this, ISA is instruction set architecture, which is the language that the hardware, the chips, these chips, computing chips speak. So usually, commonly the ones that we use is called x86. Those are all the Intel and AMD CPUs. That's most prevalent, but it is inherently less efficient. Uh, RISC CPUs are more, what do you call it, efficient by design, and there are two prominent RISC as in best designs out there. One is ARM. You may have used it in MacBooks, like or mobile phones like Android phones, iOS phones, tablets, iPads, new Apple M series chips, and even the Snapdragon X Elite desktop ARM processors by Qualcomm. So Those are the efforts in from ARM's side. ARM is a little bit more mature um, architecture, but problem with ARM is it needs to be licensed out, and you don't get access to its architecture, or you cannot design chip by yourself without licensing it from um, the ARM Holdings Private Limited, if I'm not mistaken. Um, and that is something that is very high cost commitment, and that like stifles innovation. So just because you have an idea to make something crazy, and you can put in a lot of effort to make that happen, just because you don't have a bag of money, you can't see it through. Whereas risk free does not have that. It has an open source architecture. So this is an open source architecture, so if you just have the intent, and if you want to go ahead and see it through, make it happen, you can do so. So, and people have done so. So just to put it in a perspective, um, yeah, how about this? Wait, give me a sec. Just to put it in perspective, usually all the Raspberry Pi based boards, including the Pi Pico, which is a microcontroller board, the first generation that is based on ARM, but the second generation Pico 2 is based off of, it has two cores. One is ARM, but also one that is RISC-V, and that is fantastic. And the RISC-V one is actually open source, and the person designed it. You can basically look at its source code. All the very like, was it HDL or Verilog? I'm not very sure, but I need to go check it out once more. But you can see the implementation there, and you can understand basically if you want to spin it off, remix it, and make one board yourself, you could do that. And that is fascinating, that is fantastic. And like Linux was back in 90s, it is in its infancy. It will take time to develop or mature, but by the time it matures, it is going to take over the world. This is not even a hyperbole. It has the same or similar kind of modus operandi as Linux, because and like Windows used to be the end all and be all back in that time, but gradually as the time goes on, it becomes bloated and hard to work with. x86 has the same problem. Uh, those are your, from a gaming perspective, games terminology, those are the supports that start the game very with a strong footprint, but as the game goes on becomes weak. And whereas the RISC-V Linux, this has the carry footprint, where they start the games as the weakest of all, but as the time goes on, they become really really strong. So that's where it's at. If that's an analogy that helps you understand that there's that. Okay. So enough of like basically adding perspective, but I think that was necessary because not everybody understands what RISC-V is about, what's the context about that. If you have any questions, if you're watching and if you have a question, please put that in the chat. um, right, let's oh move over to the board. We can see that this is the main chip, this is the memory. I'll have to use the camera for actually being able to read what's written. So BiWin memory chip, this is um, you see the 32 gigabit. So 32 gigabit is basically 4 gigabyte of memory. Um, Beside that, there's the mark as in the label for the boot priority for this deep switch. So it sets whether it wants to, like, you want to boot this board from flash or SD card or eMMC or UART. We'll come back to it when we want to boot it. This 4-pin header seems to be the PoE, the power over Ethernet, and this is supposedly Raspberry Pi compatible GPIO header. If I'm not mistaken, this is the CSI connector. There should be labels though. This board has surprisingly not enough labels. There is a label. It's called DSI. Basically, it's a display output, not camera. I stand corrected. Okay, and just the one just before that, beside that, uh, I'm not sure. The connector is kind of funky. I'm not sure which connector that is. Let's bring out the um, sci-fives. Okay, I'll do that after. Uh, VisionFive. VisionFive 2. Let it be there. Meanwhile, let's go back to the board. This one seems like CSI or DSI connector, like basically MIPI connector, but 4 lane, so basically 30 pin or something. 24 pin or 30 pin connector, might even be 22 pin, that is compatible with Raspberry Pi's connectors. I don't know the technical documentation. Their hardware document design resource. I'll show the page afterwards. It's so documentation is so weird. No wonder people have find challenges. By the way, as much as I know, even though all of these connectors look like they are USB 3.0 compatible connector. Basically, they have 9 pin connectors. And some two of them, basically two of them are USB 3.0. I don't know which ones, and two other ones are USB 2.0 connectors. Actually, this one is HDMI port. This is by the way audio port, and there are two Ethernet ports, which is appreciated. I like that. Having multiple Ethernet ports is always welcome. These are the 5 chips for the Ethernet. This is a header pin. I'm not sure whether it's for fan or RTC battery or some, like it will be, mostly it will be one or the other. There's another connector over here which is written like as CSI. So this is the camera connector. Actually, this particular part looks like the power management circuit. So this is probably uh, multi-phase and multi-output PMIC. I need to check which PMICs are they using. Okay, I think they need to turn it around. AXPI. AXP 15 0 150 60. Okay, AXP right, 150 60. Let's see. Yeah, found the datasheet. Pine 64's PMIC for multi-core high performance system. All right, let's show this. Uh-oh. um Overhead camera disable. Okay, let's see this. Or we can go the other way around. How about this? Here. Yep. Right. How about we go check how many power inputs are there. It's actually pretty sick. This is nice to have one PMIC that handles multiple different powers. It makes like putting all of your eggs in the same basket, but if you are designing a board where you know the power demands and stuff, then this is super useful. This makes the entire power management footprint so um, integrated and basically like compact is the word I was going for. So there are 16 LDOs. Are you kidding me? All right, 16 LDOs, one switch, six DC DC-DCs. What is DC-DC? Oh, DC-DC is in DC to DC converters. Six of them with pretty high current, basically 3.5 to like 2.5, 3.5 amps. Not bad at all. Then there are plenty of LDOs with also like the cases where you need LDOs, the hyperstable power usages there. The current demand is probably not going to be that high, mostly for the comparators and stuff. But so this seems sufficient for this. Hmm. Wow. Wow. My God, all these LDOs on the left on and all the switches are on the right. Hmm. This is the only one that says switch out. How does the other ones get switched? Are they stuck at a particular voltage? I do see the feedback coming in, but yeah, I'll need to do some more reading on this. I'll let it be. I'll come back after. It's actually pretty like nice IC. I like it. Huh. Let's go back. All right. So that's the power management circuit. Let's turn it around. And this is where the power is coming from. So this is the USB-C port. I don't know whether it does USB PD. I hope it does. I'll need to check that part as well. So, and this is a button. Probably that's a boot button. All right. So this is mostly, this side is covered. By the way, I missed out on this chip and with the oscillator. So like the crystal on the side. This seems like a VLI is probably interface chip. So probably the USB bridge is this one. Okay, turning it around, we see the first thing first, this micro SD card connector. Uh, there are a couple of these SOICs, one of which would be, let's see which one is the SPI flash. This is WinBond, so this is SPI flash. This is a flash chip. This is, I'm not so sure. It's very hard to read. Giga device 25L0 something. Let me try and search. What is Giga device IC? BIOS chip. Oh wow. Does it? This is another flash chip. That's for sure. But I wasn't. I didn't think that we have been using BIOS already on these devices, as in the um, um, like 2-year old RISC-V boards. Um, BIOS is coming on RISC-V. I don't like device trees. I don't think anybody does, and then at least in the maker community, being able to download an image and install it is much better than having a specific image built for that board, which you need to flash. That sucks. So having BIOS would be really helpful if that is indeed a BIOS chip. I'm not sure. I might be completely off, but that's what the promise is looks like. Not many other things, but basically all the storage options are on the backside. That's what it seems like. So basically, if this is BIOS chip, then it's BIOS chip. There's also flash chip that from which you can boot. I'm not sure exactly how much flash chip size is, but if we look up the markings, we would be able to tell how many MBs of flash is there. Um, you might have to compile a kernel for to fit in that small chip, but if you want to just use this board as a network switch, it has two Ethernet ports. So if you want to use it as a network switch or something, then having a OpenWRT flashed onto that chip would be pretty decent way to go. There is micro SD card, there is eMMC port. I have eMMC that will fit on this, so I want to give it a try. And there's also an M.2 connector, which seems like it only using 1x, like by one lane. Yeah, it's only using one lane, not four lanes. M.2s are capable of up to 4 lane PCIe, but this is using only one lane, and this is full sized. This is the end of the PCIe, so basically this is gonna be 2280 PCI M.2 NVMe drives. So that's this board. I am going to try it out after. Today is for some reason my luck is way off, and whatever I'm trying to get done is not getting done. um, so I might need to freshen up my brain and try it out after. uh, let's see, how is this? Yep, it worked that way. Oh, I closed it. I said that I will open up the product brief. Let's see product brief if it shows. uh, Overview, specification. No other details that I already haven't talked about. It does have board layout and everything else though, so but that's way too much. I should probably go here to show that. Yeah, it has the pick and place and everything, basically the drill size and the board actual dimensions and everything else. But not really a conversation starter. um yeah, so this is not gonna work. Hardware document, design resources, um landing page. Debian release notes. So basically, if we go to the forum, we would be able to find the current builds of OS builds that are available as well. Let me quickly search that. So SciFive Vision 5.2 forum distro collection, something like this, collection for all. Yeah, so they keep on posting this, which is actually really helpful, because if you're trying to install, this is May 2023, so I'm pretty sure there was one in uh 2024, earlier this year. uh distro collection or just collection. I don't know what keyword to search it with. Collection for, yeah, collection 2024. What? Yeah. So this one should be the latest one, where we can, yeah, the formatting is completely off, but we can see that there's alt linux, arch power, arch linux, alpine, postmarket, armbian. Armbian is gonna be interesting to try. Debian, Deepin, DietPy, Fedora, FreeBSD, OpenBSD, Gentoo, Haiku, Lubuntu, Android, OpenHarmony, OpenWRT, Pentavisor, PolyOS, RVOS. Hey, these ones I have to try. Anyways, so there's actually a like thriving community now. So if you want to try RISC-V hardware, like last year it was pretty desolate, not a lot of things going on, but this year seems to be, it has kicked up a notch. So it'll be pretty fun to try those things out. I'm gonna do that. um yeah, let me keep this one bookmarked. I'll just search with this, never mind. All right, all right, so let's close this down. Let's move back to opening the other board, which also is something that I've been waiting to open for quite a while now. This is Coral Dev Board. Uh-oh, this comes with what? This box doesn't have anything else. Should it be having something else? No, it doesn't have anything else, which is fine. It has the board, as in the documentation. So Coral is a TPU or tensor processing unit, which was the implementation of earlier implementation of the NPUs that we are talking about nowadays, neural processing unit. So tensor processing units are a little bit more general purpose neural processing units. And Google has been working on it for quite a while. They have probably released the version 5 or version 6. I don't even remember which one is the latest one. But on their data center, so you can actually get TPUs for training your like language models or whatever, like like object recognition, classification, etc., etc. All those things you can do that. For training, they are really good because they are actually massively parallel compute, way more so than GPUs. So basically, it is almost like what's CPU to GPU. The GPU to TPUs are similar in that sense, whereas the CPU goes one operation at a time, GPU does one whole row at a time. This one does one impression. Basically, a CPU prints one character at a time, a GPUs print one line at a time, and you could say the TPUs like press one page at a time, like prints one page at a time, kind of way. So they are massively parallel compute, really useful for training the models. Not previously it was not as useful for inference, like running the models, because you would, most of the time the model will sit around and not use enough compute. But if you have particular kind of load where that is useful, like basically you have enough load to run them on TPUs. TPUs are very efficient to get it done. If you can keep them completely saturated, that is to say. Otherwise, they will be a little bit costlier than GPUs for inference. For training, where it is completely saturated all the time, they are very efficient. That's where they're mostly used. And on the edge device, as in to use that TPU on the edge, so that you can basically work with the software, figure out the kinks, run the trainings on a smaller data set. Those kind of situations where you have to figure out where you have to test and validate the stack that you're working on. This is where these boards come in. This is also another, this is a dev board. This is not meant to like break any world record or anything, but this allows you to run your model with a smaller data set and figure out that the code works, because otherwise like there is not a lot of emulators and stuff where you can basically get to run that on this architecture, right? It was really crazy hard to make your code run. um, and not only make your code run, there is a lot of like multiple layers to it. Even the frameworks which will make your code run, for example the pytorch and stuff like that, pytorch, JSX, JSX, JAX, JAX. Uh, JSX is completely different. Um, Anyways, so those ones, in order to develop those and to validate that they work the way they are expected to, um, for that even you need boards like this to try them out, test them out, and see that the compatibility is there. It's not throwing random errors. The version changes of Python is not messing up with the actual development, which those kind of things might not actually get caught out in the emulation or some kind of a simulated scenarios. You need the actual thing to run that. That's where these boards come in handy. And if you want to create a smaller use case, I need to turn off the AC. This is too cold, getting too cold. And so basically, if you want to create a small enough workload that deals with, let's say, some kind of a wake word, hey Jarvis, or maybe you're just creating a baby monitor and you don't want that baby monitor, as in your baby's video data or feed, to go to any cloud. You want to basically monitor that, monitor it locally, and have it detect when the baby is waking up, whether it's in a danger or not, something like that. In those kind of situations, this kind of board will come in handy, because it has just about enough compute to detect that, to be able to infer whether uh, uh, like whatever you're trying to classify, the baby is at the edge of the board, or baby is moving around, like turning around, those kind of stuff. I'm just using baby monitor as an example. You can do a lot of other stuff with that as well. I'm just saying that if you want to do it on the edge, as in on your home, completely off the uh, cloud, you could do that with something like this. You can even use something like this as an assistive system. Like the main service happens somewhere else, like the main video, like NVR is happening, network video recording, so that is happening somewhere else, some other board, but you are just using this board to access it after the fact. Like maybe at night it's going through the feed, entire video feed, it's figuring out if something particular peculiar happened or not. Remove the part of the video that is not relevant, basically staring at the static void, and part of the video that is actually useful for you to keep, and then slicing them up, and then keeping that part later on. So those kind of things, automations, those kind of stuff would be like not only like possible, those will be very viable to do with board like this kind of smaller boards. This has 4 tops of tops, as in tera operations per second, of int 8 performance, if I'm not mistaken. So this is formidable in that sense. It's not going to break any record. It's formidable. So this is a this micro USB cable, I'm assuming, is for serial output. Like, this is an assumption. I'm not entirely certain that is the case. It looks like that. How about we pull out the Coral TPUs, Coral Dev Boards layout as well. Um, let me do that, but before that, let me just go through the whole thing and predict those things, right? Maybe I'll be wrong, some of those things. Maybe this is not a serial port, but it's fun that way. I love to be like I love to predict things and then be right about it, and if I'm wrong about it, recalibrate myself. So there are some deep switches here, very close to this. I'm assuming that's also for selecting the boot options and stuff. We'll come back to it later. Aside from that, there's a this thing, even though it looks like a crystal oscillator, because of the dot, it's actually the hole are up front on the top. I think it's a microphone. It's a MEMS microphone. Um, that it has integrated. Very weird placement though, but yeah. Again, this is a prediction. Let's see how it goes. These SMD components are really hard to see sometimes. I think I need something to point this with. Can I use this? Yeah, let's use this. So this thing is the USB's protection, like the what do you call that thing? Spike, electrical spikes, transient suppression chip. Yeah, something like that. So there's a technical name for it. I'm skipping my mind right now. This is the Ethernet port. I'm not sure if it's a gigabit. It might even be 100 Mbps. But here's the Mac, this Phi chip for it. This is the audio subsystem. So this is the audio IC. This is the 3.5 jack for it. This is, if I'm not mistaken, this is probably the speaker output. I don't know how much load can it support, but probably 3 watts 4 ohm speakers can be driven by this. um, by design, I would say that the middle two would be grounds, and the two sides from the outside. If I had to design it, I would be like, this one is left, this one is right, these two are ground for that. Anyways, so this is a button. It has written reset, so this is a reset button essentially. Fair enough. There are two USB-C ports, right? uh, I'm assuming those are data ports. There's a full-size HDMI cable. Big thumbs up for that. I do not like mini or micro HDMI ports. Full-size HDMI ports is where it's at. So much more convenient, and yeah, takes a little bit more board space, but makes it up like in all the different ways. This is a Pi compatible GPIO port. The back side, there are a couple of things as well. So this is a display connector. So apparently this is the DSI display connector. Does not seem like, or at least I'm not sure if it is Raspberry Pi compatible. And if it is Raspberry Pi compatible, then this camera port is not Raspberry Pi compatible, because they are not the same. They're not looking the same. There's a difference. So one or the other is not the normal kind, and you might have to buy or get um, camera or the connector itself from uh, Coral in order to be able to use them. There are a couple of QR codes. I don't know where they lead to, and there's a micro SD card slot here. That's pretty much it. There's a couple of power PMIC. This is the PMIC I'm assuming, and power circuits over here. There's also the main oscillator over here, crystal oscillator. So that's pretty much it. The board, actually the board is the SOM, or the system on module, that is over here. If you can see the secondary board, uh, that is lifted up like 2 millimeter or 3 millimeter above the baseboard, that is the actual module with TPU and the NXP processor, if I'm not mistaken. If I remember correctly, NXP's um, IMX8 um, SoC. So that's the module that has it, and this is basically a carrier board that expands out its IO, right? I like that it comes with all the heat sink and everything pre-applied and the whole thing. But if you were to design your own board, this has Raspberry Pi compute module like form factor, but three connectors. So you can just create a carrier board of your choice, and then you can put it up on that carrier board. I could open up, I could basically disassemble this, but I'll probably do that after booting it up first. So yeah, anyone in chat? I don't see anybody in the chat. But anyways, so hey guys, if anybody's watching, thanks for watching. Um, Today, whatever I started with the stream, it didn't go well. So please excuse me for not changing the title yet. I was trying to set up the Raspberry Pi with Minio object storage, but I was constantly hitting snag one after the other. So at the last moment, I had to basically switch gears and go for a couple of unboxing that I needed to do anyways. And so this is it. So I unboxed the VisionFive 2 first, this one, and now I'm going with like unboxing the Coral TPU board. I have been sitting on them for quite a while now. I want to start working on them. Maybe if I publish, well, as in get something like useful or done with them, I might post a video on Breakerspace. Um, okay, let's go to Coral TPU, Coral AI. All right, I think we can go here. I can close the overhead camera for the time being. Right, products, prototyping. This is the dev board. Right. So for production, you will see a couple of PCIe accelerator. So this is the SOM, system on module that I was talking about, which is let's go this mode. So this board I was talking about, this small board over here, this is the size. So this is this system on module. Let's go over there so I can show you how it is on the inside. And also let's open up this. So quick look at the system on module. It has the fan applied on top already. In my case, this fan that is applied is on top of this. This is NXP's SoC, and this is the actual the white. Oh, okay. So this screen does not show my mouse pointer, which is sad. I'll figure it out how to do that. Let's see. Window capture. Can it show window shadows, show window with empty names, but no option to show mouse pointer? So sorry about that, please bear it with me for the time being. So the white uh sh- the, the white shell, the IC with on the left, that has some KM920 markings on it, that's the actual TPU. And the blue with central black, I see that is the SoC that is in its space. So this is the ARM processor, and then there's the memory module and everything else over there. So let's quickly see the, okay, yeah, this is the top view, but more interesting the bottom view. So these three rows that you see as centipedes, those are the board to board connectors, Hiroshi connectors, that connects it with the baseboard. So, and the pin out for them, like which pin does what, that is available, that should be available over here with the data sheet that you can download. The data sheet should be here. Um, so you can download and you can implement your own board and then put it on there, boot it up, and do whatever you want with it. I think this has uh, Wi-Fi built in, Wi-Fi antenna built in. Let me just quickly see. Yeah, so this wherever you're seeing that Google and then NXP logo, that part shows the copper keep out. So basically, there's no copper over there at the bottom layer. Sorry, which is a telltale sign of having a Wi-Fi antenna. On the other side, which you can see here on the bottom left, you can see the trace, that is the antenna. All right, so this is the module. This is actually the brain of the operation, but let's go and find out the board that we're working with. Does it have the labels of what does what? Don't think so. Okay, tech spec. Yeah, so NXP IMX 8M, not 8, 8M SoC, which is quad core Cortex A53. Also, there's a M4 core. So basically, it has the CPU, also the microprocessor. Sorry, it has a microprocessor in it, also microcontroller for any if you want to get something done with the GPIs and stuff. It has the integrated GC7000. This is a, if I'm not mistaken, Imagen's graphics core. Uh, for ML accelerator, this is the start of the show. Google H TPU, 4 tops of int 8, 2 tops per watt. So basically, it takes total 2 watts. 1 or 4 GB LPDDR4 RAM. I am using the 4 GB model. Flash memory, it has onboard eMMC, but and also micro SD card. Um, Wi-Fi, as we noticed that the Wi-Fi is actually integrated. I didn't see any kind of Wi-Fi's antenna port, so you cannot add or attach antenna. If I'm Yeah, I didn't miss anything. I don't think it's there. You probably can cut off the traces and solder in the Wi-Fi antenna, but otherwise you're kind of stuck with the built-in antenna. There's a gigabit LAN, so okay, it was not 100 Mbps. I was half certain that that was the case, but it is gigabit LAN. Audio jack, digital PDM microphone, right? Two of them. I only saw one of them. The other one is somewhere else. I'm not sure where the other microphone was. Couldn't see it. Perhaps it's hidden by the module. It's under the module probably. In any case, 24 pin FFC connector for MIPI CSI camera, 4 lane. Okay, so the MIPI CSI camera is not the one that is Pi compatible. Pi's MIPI CSI connectors. So at least until now, none of them are 4 lane supported anyways. They only support 2 lanes, but the 22 pin connectors can support 4 lanes of MIPI CSI. Some of the Ardu cams actually does use Ardu cams do use that. So but it needs a lot of drivers and hardware, obviously tinkering with the device tree. But 24 pin doesn't work there, so basically that means you need different FPC cable as well as the camera that works with it. um, right, and that is probably something that you can get from here. Accessories, yeah, this is the camera, right? I'm assuming this works with this board. Right. Uh-oh. What is this random hyperlink here and there? Anyways, so that's mostly it. The data sheet, let's open up the data sheet and see what's there. Data sheet is HTML. Oh, there's a PDF version of that as well. Okay. Yeah, this is pretty detailed. If you are trying to design a board by yourself, then it will be very handy. I am just going to look into, yeah, so this is a serial console. So what I was talking about, right? So this is the part that we are interested about. So this is a serial console. I was saying that this looks like a serial control. The micro USB looks like a very poor choice for normal USB operations. So I don't blame them for using it as a serial console. It really isolates the use cases. You cannot accidentally end up plugging it in there. uh, so that's there, the DSI display, micro SD card. Everything else is exactly what I pretty much I said. uh, just that the speaker port, right? Let's see the speaker port. So right is right. Oh no, so both the sides are, oh no no no, this is very weird. Anyway, so um left is left, right is right, but positive negative, positive negative. Eh, oh well, whatever, doesn't matter, just as long as you can follow the guidelines and use it that way. But this is not intuitive. All right, the MIPI DSI pinout, that is 40 pin, 39 pin. All right, wow, this is super dense apparently. What else? Cool. Okay, yeah, this is one of the things that we needed to see as well. So boot mode. So there are four dip switches, serial download. So four boot switches, why do you need four of them? Shouldn't two of them be like suffice? Serial console off, on, switch 1 off, switch 2 on, 3 and 4 doesn't matter. Then it goes into the serial boot mode. EMMC is when the first one is on, second one is off, 3 and 4 is also off off. SD card is when same thing, the first two, and the 3 and 4. So basically the first one is just a boolean for serial download. I can totally see it as can be done with a one particular switch. And even these ones, as the one does that doesn't care, the other one is basically reverted, let's say inverted. So both of this could have been done with two switches instead of four. uh, yeah, I don't know why they chose to go that way, but anyways, so this is it. Today I'm not really feeling so hot anymore, as in I kind of lost a little bit of enthusiasm when the first thing that I was working on didn't work out. So I need some time to basically get back my energy, and hopefully if I end up streaming tomorrow, we will go through a couple of more stuff. The Yeah, today I'll have to end the stream here. Thanks for watching, and see you on the next stream. I apologize for the stream today not being as interesting as I was hoping it to be. Sometimes, Murphy's Law, yeah, that's there.